Lab 5, Kirchhoff's Rules. Amanda Acosta, Alyssa Rodriguez, Alyssa Holguin, Montserrat Nunez.
Electric circuits follow rules based on the conservation of energy and charge. Kirchhoff's rules help explain how current and voltage behave in circuits that have several resistors and junctions. Kirchhoff's junction rule states that the total current entering a junction must equal the total current leaving it because charge cannot be created or destroyed. Kirchhoff's loop rule states that the total voltage around a closed loop must equal zero, meaning that the energy supplied by the power source is equal to the energy used by the circuit components. In this experiment, a circuit with 4 resistors was built and measured using current and voltage sensors. The current through each resistor and the voltage across them were recorded. These values were then used to test Kirchhoff's junction and loop rules and calculate the percentage differences between the measured values.
The voltage current sensor was used to measure the different setups on our resistors. The connecting wires were placed to connect all of the components of this lab. It connected the sensors and resistors to get our measured data. Resistors. 4 resistors in total were used to rearrange the circuit. Each of the resistors were labeled 1 through 4. Capstone software. The software was used to display and collect measurements from the sensor. We were able to collect numerical values for both the current and the voltage.
We first began by labeling the 4 resistors R1 through R4 using tape and measured their resistance with a multimeter. Next, we built the circuit according to the schematic. Then we set up capstone to display current in milliamps and voltage. The signal generator was set to DC at 7 volts with a 10 volt limit and a 1.1 amp current limit. After that, we placed the current sensor in series with resistor 1 and connected the voltage sensor across the resistor. We clicked record, waited about 2 seconds, and then stopped the recording. Finally, we recorded the current and voltage values and repeated the same steps for each resistor.
Data. This image includes the loops and junction we use for each respective circuit. Circuit 2 and 3 have the same current. Table 1. Current and voltage values in the circuit for each resistance. This table outlines the various voltage and current findings for different circuits. Resistance 1 had a voltage of minus 1.01 and a current of 9.189. Resistance 2 had a voltage of 0.42 and a current of 1.622. Resistor 3 had a voltage of 0.56 and a current of 1.622. Resistance 3 had a voltage of 5.96 and a current of 10.811. Finally, our source had a voltage of 7 and a current of 10.811. Table 2, percent error in the measurements. Using values found in Table 1, our group had a IR4 value of 10.811, IR1 plus IR3 equaled 10.811, and had a 0% difference. We had a VE value of 7. VR1 plus VR4 equaled 4.95 and had a 29.29% difference. We had a VR1 of minus 1.01 and a VR2 plus VR3 equal to negative 0.14 with a 86.13% error. Conclusion. After conducting the various scenarios for this experiment, our group was able to learn about Kirchhoff's rules. Kirchhoff's current law, first law, states that currents will always be conserved. This means that the current flowing into a junction is equal to the current flowing out of that junction. Kirchhoff's voltage law second law states that the sum of all voltage sources in a closed-loop circuit is equal to 0. Our group was able to observe these laws using both our experimental values and theoretical equations. When calculating and comparing our current values, our group was able to observe that we had a 0% difference. This ultimately proved that using the junction rule, our values were appropriate and expected because we only had one type of junction. Thus, our findings supported Kirchhoff's first law about current. Even though our findings for current supported Kirchhoff's first law, our findings for voltage were less conclusive. When we recorded our data for each resistance's voltage, though we were assured that our values made sense, when we inputted our findings into each respective equation, our percent difference values were fairly high, since VR1 plus VR4 should have equaled to VE. Furthermore, VR2 plus VR3 should have also had a value that was close to the value we found for VR1. The reasoning for these values is of course due to Kirchhoff's second law. Because we experienced some technical difficulties with the sensor we were using, our group suspects that our errors may have partially been due to this. Even though our own values did have greater percent error, we were still able to understand how our results should have looked by using the equations provided. After conducting our experiment, our group believes that we cannot create another loop because we already tested 4 different circuits where a current was going through each sensor to measure that specific resistance and current. We predict that in order to create another loop, we would have needed to add another sensor. As stated previously, our group believes that our differences came from errors within our materials, specifically our sensor, because we have observed unique errors not only in this experiment, but in earlier ones as well that have forced us to switch out materials to find proper results. Furthermore, because our teaching assistant checked our experiment for any errors in setup, we believe that our errors were due to technical difficulties. Therefore, we believe that having access to proper equipment would eliminate such discrepancies and would make our findings more conclusive. Additionally, if we had more time to conduct the experiment, we would probably be able to identify such errors faster and would be able to check for any flaws in our materials. Despite this, our group was still able to learn about Kirchhoff's laws and the importance of them in circuits and physics as a whole. Credits: Introduction, Amanda Acosta. Materials, Montserrat Nunez. Procedure, Alyssa Olguin. Data, Alyssa Rodriguez. Conclusion, Alyssa Rodriguez. Credits, Alyssa Rodriguez. Thank you.